Hi there, and welcome to Context Free, where we talk about programming languages. Today, I'm excited to welcome guest José Valim, the creator of the Elixir programming language, which is a dynamic functional language for building scalable and maintainable applications. I'm also excited to welcome co-hosts Andre
Hi.
and Chris,
Hello.
who are professional Elm and Elixir programmers, and who are also starting their own YouTube channel, which will contain part 2 of this interview. Elixir is a programming language designed to run on Beam, the Erlang virtual machine. And Erlang is a programming language that goes along with the OTP platform. And as usual before an interview, let's look at some code. This is an example from Elixir documentation of using a gen server, or generic server, for passing messages back and forth to create a client-server structure inside of your program. Elixir manages state and structures your application via processes, which really are lightweight threads, of which you might have thousands or even millions active at once. So this is a stack that handles pop and push operations via message passing. Note also that we have pattern matching as part of the function signatures. So let's run this in interactive Elixir using Mix to compile our code, which is the build tool for Elixir. I've also wrapped this up in an application that defaults to having atom high on the stack. So if we pop from our stack by sending a pop message, we see high. We can also push there and pop again. So now we have high there, but there's nothing left on the stack. So if we pop again, we get an error, which crashed that process. However, because this process is running inside of a supervisor, it gets automatically restarted with high back on the stack again. And a typical Erlang application is built of supervisor trees for managing all the processes. And now that we've seen some code, let's move to the interview. And as usual, I've edited the interview and added visuals after the fact. Also stay tuned for part 2 of this interview, which is on Andre and Chris's channel. Topics there include NX, or numerical Elixir, which is an exciting recent announcement, as well as discussing Internet of Things and the new JIT compiler for Beam. So I'll be pointing you to this when the first part's over. So let's get on to the interview.
Yeah, so just to start out, could you introduce yourself?
Oh, yeah, definitely. So I am José Valim. I am Brazilian, but I've been living in Poland for the last 10 years or so, a bit more, 11. And I've been active in open source for, I guess, almost 15 years at this point, and I'm mostly known for creating the Elixir programming language.
Fantastic. How did Elixir get started?
Okay, I'll try to keep it short, but it's basically I started hearing more and more about concurrency and how concurrency is going to become important because, Moore's law is going to be over. So we're going to need to run our software now on multiple cores in our machine. And today, you get a watch and your watch has 4 cores. So this was more than a decade ago. I started hearing this conversation. So I wanted to get myself ready for this multi-core concurrent future. I found out about the Erlang virtual machine and the Erlang language, and I was like, I want to write software that runs on that platform. And that eventually led me to create the Elixir programming language as a way to explore the platform and try different things.
So after you wrote the language, what do you think helped the Elixir community grow?
So one of the things that I knew early on, and that was probably coming from my experience, so I was active in the Ruby on Rails community before, and was something that I probably learned from my time with Rails is that marketing is part of your open source work. You need to go out, you need to talk to people and to make sure that people can have a good onboarding experience, can learn how to do things and learn how to progress. So I think the initial growth, at least, has been because of that, being focused on this getting started experience and going out and telling people like, hey, try this out. And also, a lot of the reasons is the Erlang virtual machine. I fell in love with it for a bunch of reasons like concurrency, distribution, pattern matching, functional programming, and being able to tell people like, hey, you have access to this wonderful platform with all these features also help bootstrap, I think, the growth of the language. Yeah, so that's where I would go as the getting started and why it grew and how it grew. And then from there, organically, people started using it, telling other people, and so on.
So by at least some metrics, Elixir has been more popular than Erlang in recent years. How do you feel about this and how do you think this happened?
So this is interesting. I haven't really thought, as you can see on my reply, I haven't really thought much about it. I think like for me, I'm very clear Elixir wouldn't exist without Erlang. Literally, it wouldn't exist. So I consider the success that we have is because of Erlang. So I don't necessarily associate those things as different things. We succeed because of them. And I'm hoping that they can also succeed more because of us. So that's kind of my take on it. And the platform continues advancing. So they just announced Erlang OTP 24, the release candidate, and it's coming out with JIT. And now all Elixir code is for this first iteration of the JIT. We are seeing like improvements from like some things are twice faster, some things are like 40% faster, and it just comes for free. And all of this is amazing. So we are really tailcoating on their success rather than the opposite.
So, what relationships or contributions exist between the Elixir team and the Erlang OTP team?
Oh, yeah, I love this question. So I'm going to tell a story. When I first announced Elixir in the Erlang mailing list, I recognized that I did a mistake because when I announced it, I said Elixir is a modern approach to programming on the Erlang virtual machine. And you can totally see how that's not a good way to get started, right? So totally my bad. And then, of course, there was some opposition because of that. And while, people are like, oh, modern, right? Having that discussion. And I was like, oh, somebody from the OTP team, they said, like, don't worry. I don't remember who it was. And I can probably go and check. And I told the story a lot of times and I never went back to check. And I kind of actually like at this point, not knowing exactly. But somebody sent me a message saying, we think what you're doing is really interesting. So continue doing that. And so there's no official relationship. It's like any relationship between open source projects. I send pull requests, they give amazing feedback. Sometimes they want to do something that I have already explored, they reach out for feedback, but it was always very open, very welcoming, and extremely helpful every time I had to reach out to them because I thought something could be better. Even if I was wrong, they would say, hey, we tried that, doesn't work, or, oh, this is nice. We would love some contribution. So very productive and open.
How does Elixir governance work?
Okay, so there's a lot to unpack here. From the beginning, I've always tried to keep things as decentralized as possible. And one of the reasons for this is when Elixir started, I was one of the founders of a consultancy called Platform Attack. We were like, I think when we started, maybe between 20, 30 people. And when you looked around, you would see Apple was coming out with Swift. There was Microsoft with F Sharp, Google coming out with Go, Mozilla with Rust. So when we looked around us, we are kind of competing between quotes. Like, we need to get developers' attention with those languages that are banked by really large corporations with really big amount of money. So since the beginning, I tried to take a very decentralized approach, which was I'm going to be responsible for a small set of things. So for example, what are Elixir official communication channels? It's like IRC that not a lot of people use nowadays, and like GitHub, right? And I know other languages, they do have a full community team and documentation team, but for us, like, no, we are going to take care of this. And it's not because we don't think the rest is important, but what we're going to do is that we are going to leave the space open for people in the community that care about those things to come and leave their mark and make what they want the space. In a way, we have a kind of guidelines of being an open, welcoming community, but we leave it to the community to reciprocate that. And I think this is important because there are things like, I know there is a Telegram Brazil group, which I could be part of because I'm Brazilian and speak Portuguese. But I also know that there is a Telegram Russia group, but I don't speak any Russian. So I cannot really be responsible for that. So I think giving everybody, not really a blueprint, but kind of like the general direction, it's more important to let everybody contribute. When somebody comes and create their forum and motivates the local community, they also feel like they own and they are responsible for it. There are some things that are really important to us and we are responsible for those things, like the core, but everything else we let people come and make things their own. And this also impacted on the language design. So the language was designed to be extensible. So you can get it, take it to new domains without having to change the language or without having to ask the Elixir core team what they think about it so it gets approved. A lot of the tools we use to build a language, they are available for everybody to build the ecosystem, to build a library that they want. So that has been our general approach. But like for the specific governance of things on our website, there is a page called development that now I'm wondering if it should have been called governance. But that kind of describes the core team. We are a group of 6. And what are our responsibilities, what you should expect from us, what you should expect for the language. It's a very light read.
Awesome. Going more to the language itself, syntactically, it's very clear that Elixir differs from Erlang. What other important differences are there, and how did you make these choices?
Okay, so when I started Elixir, it was really a prototype, and I made a bunch of mistakes. And I think one of the biggest mistakes I did was that I was really trying to depart way too much from Erlang and the Erlang virtual machine. So when I did the rewrite that would eventually become the Elixir that we had today, I've kind of set that I want to stay as close to Erlang as possible. And I've identified a few things that I think needs to be different because I want a couple of things to behave differently or because I think a particular feature is important. So in terms of semantics, it's very, very close to Erlang. Everything in terms of concurrency, distribution, the data structures, everything is the same. So when it comes to the data structures, we share the syntax as much as possible. So the same way a data structure works in Erlang also works in Elixir with very few and rare exceptions. But the thing that is clearly different is the syntax. And originally, I knew I wanted to have metaprogramming. And I started with a metaprogramming that was very similar to how metaprogramming works in JavaScript or Ruby and Python that is very dynamic in nature. And I realized that that was not going to work in Erlang because we usually do compilation ahead of time. So I knew I wanted metaprogramming, and then I knew that approach that I tried was not going to work. And then I realized, hey, there's this Lisp family of languages, and this combination of Lisp-like macros is going to be a really good fit for the things we want to do. And when I started Elixir, there were 2, maybe 3 other Lisps in the Erlang virtual machine. And I was like, I want to try something different. I want to have Lisp-like macros, but I don't want to work on the S expressions thing. I want to have a higher level language that translates to the ST and try to mix. And given my background in Ruby, there were a lot of Ruby influences in that higher level language. And there was also some influences coming from Clojure. And I think those 3, Erlang, Ruby, and Clojure, are the 3 main influences of Elixir. It's very interesting because later I learned that on the papers that introduced Lisp by John McCarthy, he introduced SLisp, which is what Lisp became famous, but he also introduced MLisp, which is a higher level language that translates to SLisp. So I was, oh, this is interesting. I'm not sure if anybody explored this before. It's like, nope. In 59, somebody explored that idea. I am like 40, 50 years late. But yeah, so that's kind of the history behind the syntax and how they differ.
Awesome. And you've mentioned Ruby a couple of different times already. How much do you think the Ruby syntactic similarity contributed to the growth of Elixir, and or are there other important similarities or differences we haven't already discussed?
I don't know, honestly. And those are the things that it's so hard to assess unless we can go back in time and fork distinct realities so we can compare. It's really hard to know. And the thing about syntax is my goal was not necessarily to have Ruby syntax. That was not the point. The point was I wanted to have metaprogramming with macros and I need to have a higher level syntax. So for example, when you compare Elixir with Ruby, after the initial 2 hours look, you can really see there are a bunch of important differences. And Elixir syntax is much more regular because that's important for the macro system to work. Anyway, so Elixir uses do-end blocks, and I think that's going to be like the most thing that you're going to look at and say, hey, this looks like Ruby. But I think, well, what if instead of do-end blocks, we used curly brackets? I think about this stuff, even now, like a decade later, knowing that I can't do anything about it. Or what if it was indentation-based? And I can explain myself out of those things, I think sometimes for my own sanity. So for example, if we go for curly brackets, one of the issues is that I wanted to have the same data type syntax as Erlang, and Erlang uses curly brackets for tuples. So that was probably the decision why I say, hey, it would be ambiguous. So that ruled one thing out. But then being like Python, for example, for sensitive white space, mixing that with macros is probably going to be asking for way too much trouble because how you're going to express the AST construction with sensitive white space, it's probably doable. It's probably going to have a bunch of sharp edges. So yeah, I don't know exactly how to quantify that. And there are like so many different paths it could have taken. And I don't know how to make out of it.
Good enough. And in terms of, I think you already might have hinted at it earlier, but one of the things that was interesting in the semantics of Elixir early on was the ability to reassign variable values, and you removed that along the way. Why did you want it, and why did you remove it?
Oh, so just to be clear, you can reassign variables. There's a lot of discussion about this, but I think they are important in Elixir because of macros. So imagine that they have a macro, for example, that sometimes needs to collect some information as you call the macro. The variable is a good way for you to have something that is collecting lexical information. So there are some use with it. But there are a couple of interesting changes that we did. So in Ruby, you can call things without parentheses. But there is a ambiguity, which is if you want to call a nullary function, a function that expects no arguments, for example, like foo, you can write foo, and that foo may mean two things now. It may mean a variable foo, or it may mean calling a function foo with empty parentheses that has no arguments. And this is obviously ambiguity, and that's something that we added at the beginning, and we deprecated it. The reason for that was because we want the code to be clear. I don't want to look at the code and have to look at the surrounding scope to figure out if that thing later is going to be a function call or a variable. And maybe we introduce a variable above, and that's going to change the meaning of some code later on. So we wanted the code to be clear in that area. So that was something that we did. And the other thing with variables, and it actually what we were thinking about originally, is that Elixir at the beginning, as Erlang, only had a single scope inside the function. So if you have a variable, say like foo equals 1, then you could do, if some condition do foo equals 2, that will conditionally set the variable foo. The issue with this code is that imagine that you are refactoring and you get this if block that was setting foo equals 2 and you move it to a separate function. Now that code is no longer going to behave the same because you were relying on the side effect of that block to change the outer scope. So what we did in Elixir that doesn't work. What you would do is a much more functional approach, which is you would say, hey, foo equals 1. And then if I have a condition, you're going to say foo equals the result of the if block. And then the if block is going to say, hey, if this condition, I'm going to return 2, else I'm going to return the original value of foo. And that makes the code much clearer. You know that as you enter inside function calls, as you enter inside conditionals or whatever, you know they cannot change the variables that are outside. It gives a much more linear reading of the code. And it makes refactoring a breeze because if you have a condition and you say, hey, I actually want to extract this to a separate function, you know that I can literally just get the code, put it in a function, pass the arguments, and it will just work. You don't have to chase variables that may be implicitly being set and changing. When writing the code, sure, is it more convenient to set the foo inside the if and forget about it? Sure, but we want to optimize for reading. So we've made decisions along this way where we steered away from the language we are inheriting from.
So going alongside with readability and clearness, I work a lot with Elm at work at Corvus Insurance, and we have Elixir in the back. And one thing that really gets to me is the lack of static typing. So what's your take on static typing for Beam languages?
This is a very relevant question, and there is a lot of languages and people exploring static typing for the Beam. And I'm really excited about that because if somebody comes up with a great solution, I'll be completely fine to say, hey, we are bringing that to Elixir, or thinking about how we would bring that. But it is a complicated problem, especially considering that there is an existing language with existing features. And I think there is a delicate balance. And I think Elm, for example, is a language that tries to balance that really well. Elm really does a lot of effort on keeping the whole type constructs simple. The thing about typing is that it's going to forbid you to write some programs, right? It's a given. So there is, in a way, a loss of expressiveness. There are some programs that you would like to write, but you can't write it because you can't write a typing rule for that. So if the type system cannot understand it, you can't have that program. That program is therefore invalid. So you have to juggle all those balls. And then when you consider that, hey, we have a platform with existing code that one focus a lot on concurrency using the actor model. And then you also need to figure out how you're going to make all of that work with distribution and other features like code reloading. So it's a very vast area with a lot of things to explore, but it's something that I'm personally interested. So there is a language called, I think it's Hammer, which is Haskell with Erlang. And I really like how they tackle the problem of how I'm going to type agent server, for example, which is a generic abstraction we use in Elixir for making process behave like client and server inside the same virtual machine. So I really like their solution to that problem, right? And then I think everybody contributing with those different kinds of solutions maybe in the future, we can get to a point where I can say, hey, this looks good. And we can bring some of it to Elixir. So you can have a subset of Elixir that is going to be typed. But it may take 10 years. It may take 20 years. It may take 5. It's really hard to say. People have been trying to type Erlang for decades at this point. There are papers, I think, from the 90s. But I think we can make headway into that. The other thing is that there's a bunch of things that people wrote in Elixir today that cannot be typed because a type system is always going to reject some software that is valid today. But because that code is already valid today, you can just say, hey, so don't type it. It's fine for us to have a subset and maybe making some of those features available only to the subset of the language, which would allow us to tackle the problem gradually instead of trying to come up with a whole design upfront. And we've been making the Elixir compiler smarter bit by bit by using type information, but that's a step that's very, very far away from actually having a type system. And, it's fine. We'll continue to improve things slowly. And if we ever feel confident, like, hey, this model is really good for us, then we can talk about it more seriously.
And that's part 1 of the interview. Look in the description for a link to part 2 on Coding Cave with Andre and Chris. And while you're there, take a look at their other videos on functional programming languages.